Hello everyone, my name is Cristian. I'm going to present my work Metabiome, a flexible and modular pipeline for metagenomic analysis. As a general context, as you may know, metagenomic analysis involves several bioinformatics software in order to go from raw reads to interpretable results. To tackle this challenge of using several bioinformatics software, tools such as pipelines and workflows have been developed in order to automatize the analysis throughout. However, some of these metagenomic pipelines tend to lack one of these three main aspects, which are the flexibility, the user choice, and the ease of use. That's why we have proposed and developed our brand new metagenomic pipeline, Metabiome. As you can see here, this is the Metabiome workflow, and the Metabiome structure is quite simple. It's an open source pipeline that you can find here in our GitHub repository. It has several bioinformatics software wrapped in bash scripts and containing code environments, which we'll call modules. And it has three main steps: the data preprocessing, which consists on the quality screening and filtering, and the decontamination of the raw reads, and the read-based analysis, which consists on the analysis based only on the reads, and the assembly-based analysis, which consists on the analysis based only on the draft assemblies. Moreover, we have also tested our pipeline and successfully reproduced Chung et al.'s 2020 mouse gut microbiome study. At the end, why should you use Metabiome? You should use Metabiome because of the three main aspects that I mentioned, because of its modularity and flexibility, because Metabiome's functions are contained code environments or modules, and these modules allows the user the flexibility to choose which of the modules to use and which of the options of each bioinformatics software to use as well. And because of its easy use, Metabiome has a pretty easy and intuitive command line interface, as you can see here. Metabiome, the name of the software, and the required options.
Thank you very much for your talk. It seems quite interesting, really. Other questions for Cristian? Please do not hesitate. And if there is not, I have also a little naive question if you want to answer.
Of course.
This question is really really naive, but seeing your pipeline, it's simple. It's how do you decontaminate the raw reads? Because I know how we can filter it, but I never heard of that term before. Can you tell me a little more?
Of course. Through our pipeline, Metabiome, you can decontaminate your reads through three approaches. At first, you can analyze the quality of the reads through FastQC, and then based on those quality evaluations, you can perform the trimming with Trimomatic and also Babadook, which they have different algorithms to trim the low quality bases, the vectors, adapters, and also low complexity regions, which are also problems in raw data from short read sequencing. And then we also provide a script with Bowtie2 to align the reads to the human genome and the PX genome, which is a currently vector used in sequencing platforms. And then you can also align those reads to the genome of your choice. For example, in the study from Chung et al., they studied the mouse gut microbiome. So we also use our Bowtie2 wrap script to align our reads to the mouse genome in order to remove those reads.
All right, thank you for your explanation. There are two questions right now. The first one.
Yes, nice question. Yeah, we have also tested our pipeline in a rhizosphere microbiome, and we also got pretty good results in comparison with the investigation they came from. And also, we are now working in a much bigger data set from also rhizosphere microbiome. So we are also working our pipeline through this data, and it's giving nice results. And what was the last part? What other applications?
The computation part? Application would be
how
possible.
the computation time is, we are working on that. We have tested with 16 processors, one node, and more than 800 of RAM, and the whole pipeline from reads to max, which are metagenome assembled max, can depends of the data. But for example, for the mouse microbiome study, it lasts mostly 1 week. 1 week to run the whole pipeline, because there are some section of the pipeline, like the assembly and the binding of the draft genomes, that take a lot of time. But we are working on that too. And yes, Metabiome was previously designed to only short reads like Illumina or BGI, and we are not sure. We haven't tested all long reads, but I don't know. We will check on